Welcome to today's lecture on technology obsolescence and preservation. The story of libraries is the story of humanity's effort to record, share, and protect knowledge. It started with spoken stories passed down orally, moved through manuscripts, printing, film, and finally to digital information. Each technological leap has made access easier, but has also created a new preservation challenge. Nothing we build lasts forever. Paper yellows, disks corrode, servers fail, and file formats vanish. So as librarians, our job isn't just to collect information, it's to make sure that information survives technological change. In this session, we'll look at what media live in our libraries today, how long each lasts, and what strategies we use to keep collections accessible even as the technologies behind them disappear. When we talk about media in libraries, we're talking about a living ecosystem of formats that coexist and evolve. Let's begin with paper. For centuries, it has carried our written memory. Even though digital publishing is expanding rapidly, paper remains the foundation of most library collections. It's inexpensive, familiar, and readable without electricity. The technology of printing hasn't changed dramatically in over 100 years, though the quality of modern paper has declined because of acidic pulp and mass production. That makes preservation, proper humidity, temperature, and pH control especially important. Computer memory now underpins almost everything else. Libraries hold vast amounts of electronic resources stored on servers or vendor platforms. Terabytes of books, journals, videos, and datasets sit on hard drives and solid-state drives. They give us speed and scale, but also fragility. Drives can fail without warning, licenses can expire, and servers can be decommissioned. And then we have audio files. Instead of shelves of cassettes and CDs, many libraries now provide access through online services and downloadable platforms. This has improved convenience but created dependence on third-party providers and constant changes in file formats. Taken together, these formats illustrate how the library has shifted from being a warehouse of physical objects to being a hybrid environment where analog and digital information coexist, each with its own preservation challenges. Let's look at how libraries physically store digital information. Hard drives are the workhorses. They spin thousands of times per minute and can hold several terabytes of data. They're fast but mechanical, subject to wear, vibration, and electrical failure. Solid-state drives are faster and quieter because they store information in electronic cells instead of spinning disks. But each cell can be rewritten only a limited number of times, and data may begin to fade after years of inactivity. USB flash drives provide mobility. Staff and patrons use them to transfer files or run small applications. They're inexpensive and convenient, but not durable, easily lost, and prone to corruption. Magnetic tape remains important for long-term storage and backup. A single tape cartridge can hold massive amounts of information at low cost, and it can sit on a shelf for decades if stored properly. The downside is that it reads data sequentially. You can't just open a single file instantly. The lesson here is that no medium lasts forever. Every device requires maintenance and migration. The key to preservation is not finding a perfect material, but developing a plan to refresh and copy data before any system fails. Digitization has become one of the most important ways libraries protect and share information. Scanning allows us to convert physical materials, books, manuscripts, photographs, into digital images. High-quality scans should be captured at a minimum of 600 dots per inch and full color depth to preserve fine details. Once scanned, documents can be processed with optical character recognition, which turns printed text into editable, searchable files. This not only preserves the content but makes it discoverable and accessible online. Libraries use digitization for many purposes: to reduce handling of fragile items, to create digital exhibits and institutional repositories, and to provide online course materials. But digitization doesn't end preservation. It begins a new stage of it. Every digital file must be stored securely, backed up, and migrated to new formats over time. In other words, scanning saves information from physical decay, but it also commits us to long-term digital stewardship. Preservation isn't limited to the professionals behind the scenes. Every library user participates in it in small but meaningful ways. Traditional copying and printing services remain essential. They let patrons reproduce materials quickly and affordably, ensuring that information can travel beyond the walls of the building. Emailing and downloading options, now common in electronic databases, extend that idea. Users can send articles or book chapters to themselves or save them directly to portable drives. Scanning has become an especially valuable service. Modern multifunction devices make it easy for patrons to capture high quality PDFs of documents at no extra cost. These activities teach important habits of personal archiving, how to store, label, and back up digital copies. By offering these tools, libraries help patrons build their own capacity for preservation, turning every user into a small-scale steward of information. Different materials have very different lifespans, and understanding those differences is vital for long-term planning. Under good conditions, microfilm can last roughly 500 years. Books and paper range between 100 and 500 years, depending on quality and environment. Once we move into digital and magnetic formats, lifespans shrink dramatically. Blu-ray discs might survive 50 years, magnetic tape around 20 to 30, VHS tapes and audio cassettes maybe 10 to 20. Solid-state drives and hard drives can begin failing in just a few years, especially if left unpowered or heavily used. Even CDs and DVDs, once marketed as permanent, may degrade within a decade due to oxidation or layer separation. The paradox is that the newest technologies often die the fastest. To preserve content, libraries must plan regular refresh cycles, copying data to new media every few years and verifying its integrity through checksums or audits. Preservation today is a continuous process, not a one-time act. Archival work involves more than storage. It's a series of strategic choices. Hardware and software availability come first. Every digital file depends on something to interpret it. If the device or program disappears, access vanishes too. Maintaining at least one functioning copy of the hardware or an emulator is essential. The best format for preservation is another crucial decision. Some items should be kept in their original form for historical value, others should be converted into open, standardized formats to guarantee longevity. Next is the storage environment. Temperature, humidity, and air quality determine how long physical media remain usable. Ideal conditions may not be possible everywhere, so prioritization is key. Reserve optimal space for the most irreplaceable materials. Always keep multiple copies in separate locations. This practice balances access with safety. One copy for public use, another protected as a master. Finally, think about future use and significance. Not everything deserves infinite preservation. Selection policies help ensure that resources go to materials most valuable for future research and cultural memory. In short, preservation is both a technical and ethical decision-making process. Digital preservation introduces a different set of risks. Every organization accumulates enormous volumes of emails, web pages, and office documents that tell its story. But when staff leave or servers are replaced, those files often vanish. Drives get reformatted, accounts deleted, and valuable institutional memory disappears overnight. Preventing this requires clear policies, regular backups, documented workflows, and long-term archives that outlive any individual employee or system. Digital materials must also include metadata, information about when and how they were created, by whom, and in what format, so that future librarians can interpret them accurately. Preservation systems must check file integrity regularly and migrate content as software evolves. It's not enough to save bits. We must ensure that those bits remain readable and meaningful. The deeper message is that preservation is a matter of organizational will. Technology can help, but success depends on consistent planning, resources, and the commitment to treat digital information as a permanent part of the collection. No technology lasts forever. Every format eventually reaches a point where it's no longer supported or practical to use. Some are already gone. Audio cassettes, compact discs, floppy disks, film strips, VHS tapes, and zip drives. Their playback equipment is either rare or non-existent. Even when the objects survive physically, the means to access them may not. Others are slowly disappearing. Photocopiers are giving way to scanners and smartphone cameras. DVDs are fading as streaming dominates. And microfilm, though durable, has fewer and fewer users who know how to operate it. The next group at risk includes print periodicals, non-searchable digital text, and e-books that can't be downloaded. Each faces declining demand or technological barriers that threaten future access. Recognizing these patterns helps libraries act before it's too late. By monitoring usage and equipment availability, we can decide when to digitize, when to migrate, and when to retire a medium entirely. In doing so, we avoid unplanned obsolescence and preserve the information itself even if the original format disappears. Looking ahead, library collections will continue to diversify rather than collapse into a single format. Print, analog, and digital media will coexist, each serving different needs. The challenge is to maintain flexibility. Preservation plans must include scheduled migrations, sustainable funding, and continuous staff training. No one policy will fit all materials. Instead, we'll need adaptable systems that evolve as technology changes. Collaboration will play a growing role. Shared repositories, regional preservation networks, and cloud based backup systems allow libraries to distribute costs and reduce risk. At the same time, we must recognize that obsolescence is part of the natural life cycle of information. Retiring outdated formats isn't failure, it's responsible stewardship. By focusing on the content rather than the container, we ensure that knowledge survives. Ultimately, the mission of the library stays the same: to safeguard access to information for generations to come. As technology changes, that mission doesn't weaken, it becomes even more essential.